Effectively, if there's a population increase of by a factor of 4, the increase in the energy usage currently is going up by about 16. And if we start looking at this slightly more carefully and start looking at a snapshot, if we look at the last recent years, 10 years or so, the world consumption of energy is shown here in the purple line. The United States alone is using about a quarter of the world's energy. There is China and Russia close behind. But that's not the key issue. The key issue is that the share of the population is around 5% of the US. The energy production is about 17%. But the energy consumption is about a quarter. So as the population increases, although the production increases, you're not catching up with the consumption. People want more and more luxuries associated using energy, and that is creating a problem as to where is the energy coming from and what is happening with the energy that's out there in terms of pollution. It is even worse because if you start looking at projections of energy usage in time to come, and if we say that we are around here, and this is shown energy usage in CODs, you can see that there is this huge increase that's going to happen as the population increases and we need more and more things. So we need to start thinking about an energy mix that can be more efficient. Looking at the demographics again, you can see that one of the drivers that's driving this huge increase in energy demand is associated with the developing countries. And within the developing countries shown here in green, the increase exceeds the industrialized states simply because the industrialized states are starting at a much higher level. So the percentage change may be larger for developing nations, but it's just catching up. And it's their right in developing and coming up to the industrialized states that you need to have energy. But what we need to have is clean energy sources, renewable energy sources, rather than energy sources that can potentially damage the earth. If you look at the energy mix, again, this states a lot of things, and this is taking a developed country such as the US. If you look at the input into the energy, what you notice is most of this comes from coal, natural gas, crude oil imports, etc. So if you look at the energy mix coming in, around 84% of that is associated with fossil fuels. And we know that when we burn fossil fuels, we have problems associated with the emission. And we not only have problems associated with the emission, it's not a renewable product that you have. It's millions of years of fermentation to create these products just going out in smoke in a few seconds. If you look at the mix also within the US, there's about 8% nuclear and only 6% renewable. If we compare that to the UK current energy mix is about 75% from primary sources. It's mostly coal and gas, not so much oil. 18% is nuclear as opposed to the 8% here, and about 4% renewable. So what you notice is most of the developed countries are relying heavily on fossil fuels. Now, I know this is a busy graph, but then if you start looking at what this energy is used for, it really becomes imperative as to why you need to change the things. If you look at the energy lost in using these energy sources, it's staggeringly large. 80% of energy use in the transportation sector is lost. Overall, in the total energy equation, 58% of the primary energy is lost as waste energy, and it's not used. So really, although the energy usage is going up, much of it is not being used properly. So we need to have a solution. So the key issue really is your population is increased, and this is a semi-log plot. By 2050, you'll have about 10, 11 billion people. The per capita growth with GDP is increasing. Although the energy consumption per GDP, because of the efficiency gains, is decreasing, the increase in per capita is higher than the decrease, and therefore there is a disparity. So the issue really we have is we need more energy, but the energy that we get has to be used more efficiently. And if we can reduce that and replace that fossil fuels and primary energy with renewable energy, it means that it can solve many of the problems and issues we are facing today. If we take the renewable energy sector and dissect that, what you find is that much of it is biofuel based. You have a little bit of solar and some conventional hydroelectricity coming from this. But these numbers are very, very small in comparison to the total energy that is required. Now then the question comes, if this is the issue, why don't we start using solar? Or why don't we start using another technology tomorrow? The issues there are simple. That roughly speaking, these costs are very close to the 2002 cost still. If you were to use any of these primary sources of energy, the cost per kilowatt hour of producing it is between 1 or 2 and 8 cents. If we try to replace that with something like solar, the cost is about a factor of 6 higher. And this is not acceptable to the consumer, and that's why you need huge government subsidies in order to help reduce that shock. Wind and nuclear are lower, but the investment that you need in order to put wind solutions and nuclear solutions are significant, and they also have to be taken into account. And why is this increased energy, particularly using fossil fuels, hurting us so much? It's hurting us because by having fossil fuels burning inefficiently, it means that your CO2 levels are increasing. And this work that was done by the IPCC, Intergovernmental Panel on Climate Change, analyzed Antarctic ice cores and showed that there is a very significant correlation between the temperature of the Earth at its current state and CO2 levels. This correlation showed that for many hundreds and thousands of years, and this is going back 400,000 years before the present, there was only a 12-degree centigrade shift in temperature for the changes in the CO2 level. The CO2 level never reached above about 280 parts per million. Currently, your CO2 level is up to about 380. So there is this anthropogenic climate change that is being predicted. And this CO2 level means that the temperature here will rise. And the question is, how far will it rise? And whether it's too late even now to be able to reduce the changes that are going to happen with climate change. So what we need to do as good world citizens is noting the fact that these various countries are giving out and using lots of energy. How do we stop fossil fuels really being burnt or making fossil fuels more efficient in its burning using technologies? Now, very quickly, in terms of industrialization, we've seen the first industrial revolution in the 18th century that started in the UK with the steam engine, followed with the second that brought us railways, the third industrial revolution that brought us electricity, the fourth one that was based on electronics that was based around the US and the Pacific Basin countries, Japan, etc. This brought us computers, and it brought us various chemical synthetic processes, organic chemicals. There is now talk that the fifth industrial revolution is going to take place, And one of the areas that this could be based around is nanotechnology and molecular electronics.